our main goal for today is to discuss about correlation and linear regression. Okay? If you saw or if you heard the word correlation, what do you mean by that one? In your own perception, what is a correlation for you people? Any idea? What do you mean by correlation? If you saw that word or if you heard that word, what do you mean by correlation? In your own perception, how do you define it? When we say perception, there's no wrong answer. Okay? So in your own perception, in your own words, how do you define correlation? Anyone? When you saw the word correlation or when you heard the word correlation, how do you define it? Anyone? Any idea? What is a correlation for you?
Miss, I think it has something to do with like relations with different populations.
Okay, very good. So when we say correlation, you are referring to a relationship. Okay, a relationship. That's correct, my dear. Okay, let's proceed now. So start with correlation. Okay. So when we say correlation, let me change the video. Okay. Okay, here we go. So when we say correlation, it's a relationship between two variables. Okay. The data can be represented by the ordered pairs. Okay, x and y, where x is the independent or explanatory variable, y is the dependent or response variable. Okay, I repeat, when we say correlation, like what you said a while ago, my dear, it's a relationship between two variables. Okay, and these variables, we come up with ordered pairs, and that will be x and y. Okay, where x is your independent and y will be your dependent variable. Okay, a scatter plot can be used to determine whether a linear, okay, linear means straight line, correlation exists between two variables. Okay, example, so we have x and y variable. So for x variable, so you do have elements 1, 2, 3, 4, 5. And then for y variable, you do have elements -4, -2, -1, 0, and 2. Okay? So using the scatter plot, you need to determine whether the line or the straight line or the linear correlation exists in the given variable. Okay? So that's the main purpose of scatter plot. So linear correlation can be classified into 4. Okay? So we do have negative linear correlation. Means what do you mean by negative linear correlation? When we say negative linear correlation, as x increases, y tends to decrease. Okay? That's negative linear correlation. So the relationship of that particular variables, okay, we call it negative linear correlation. Okay? There's a relationship between two variables, and this relationship, it's negative relationship or negative linear correlation. Why is it becomes negative? Because if your x increases, your y tends to decrease. So that's negative linear relationship or correlation. Okay? Then the other one is the positive linear correlation. Okay? This one, how do we determine the positive linear correlation? Meaning, if your x increases, y tends to increase. Okay? So they are both increasing. So that's why we call it positive linear correlation or positive relationship. Okay? Both variables tend to increase. So that is positive linear correlation. Okay? When we say no correlation at all, meaning there's no cause and effect on both variables. Okay? So there's no correlation. Non-linear correlation, okay, it will not form a linear or a line, straight line. So that's why we call it non-linear correlation. Okay? It can be a curve, okay, but it can be a negative curve or a positive. So it depends. So that's a non-linear correlation. Okay? So when we say correlation coefficient, it's a measure of the strength and then the direction of a linear relationship between two variables. The symbol R represents the sample correlation coefficient, and then the formula for R is this one. So R is equal to N multiplied by the summation of the product of X and Y minus the summation or the product of the summation X and then the summation of Y. All over the square root of N multiplied by the summation of X squared minus the summation of x raised to 2 multiplied by the square root of n, okay, multiplied by the summation of y squared minus summation of y squared raised to 2. Okay, I'll give you an example later on. So the range, take note of this one. So the range of the correlation coefficient is -1 to a +1. If x and y have a strong positive linear correlation, the value of your correlation coefficient, okay, which is denoted by R, is close to 1. Okay? Likewise, if X and Y have a strong negative linear correlation, okay, the value of your correlation coefficient, which is denoted by R, is close to negative 1. Okay? If there is no linear correlation or a weak linear correlation, so the value of your correlation coefficient, which is denoted by the symbol R, is close to 0. So very weak yung relationship. If the value of R is close to 0. There's still a relationship, but it's very weak. Okay? So for example, okay, this one. If the value of your R, okay, when we say R, you're referring to the correlation coefficient, okay, is equal to negative 0.91, then we can say that the relationship is strong negative correlation, okay, of the two given variables. But if the value of your correlation coefficient, which is denoted by R, and that will be equal to 0.88, so the relationship, can we say that it's a strong positive correlation, okay? But if the value of R is 0.42, okay, it's still within the range of negative 1 to 1, but still, it's a weak positive correlation, okay? Because it's closely to the 0. Okay? Kapag closely to 0, there is a relationship, okay, but it's very weak positive relationship, okay? And then, if the value is 0.07, that is non-linear correlation, okay? So how do we calculating a correlation coefficient? So these are the words, these are the symbol. So number 1, find the sum of x values, meaning the summation of x. Number 2, find the sum of y values, meaning summation of y. Number 3, multiply each x value by its corresponding y value and find the summation, okay, the summation of the product of x and y. Square each x value and find the sum, or the symbol of that one will be summation of x squared. Number 5, square each y value and find the sum. Okay, in symbols, we call it summation of y squared. Use these 5 sums to calculate the correlation coefficient. Okay, so for example, calculate the correlation coefficient R, denoted by the symbol R, for the following data. Okay, first we need to what? Find the sum of x. Okay, find the sum of x. So find the sum of x, meaning you need to get the summation of your x values. Okay, so how do we get the summation of x values? Can anyone? Can anyone answer my question? How do we get the summation of x values? Anyone? What do you mean by summation of x values? Meaning what? Meaning what? Hello? What do you mean by summation of x values, my dear people? Meaning what? Any idea? What do you mean by summation of x values? Meaning you need to? Meaning you need to what? You need to? Can anyone answer my question? You need to what? Summation. Meaning you need to? What is the operation involved? My dear people. Meaning you need to? Summation. Okay? Okay, very good. So you need to add. Okay? So in this particular example, so what will be your summation of x? Before I give my answer. So what will be the summation of x? Okay? Some of your classmates said that you need to add. So what will be the summation of your x values? Okay, someone answer it. Okay, very good. 15. Next. What about summation of y? Summation of y. Meaning you need to add. Summation of y. What is the answer? Let's see. Okay. Negative 1. Next. Next, summation of xy. Summation of xy. What about summation of xy? So you do have 9. And then summation of x squared, you do have 55. And then summation of y squared, you do have 15. Okay? So how do you get xy? So to get xy, meaning you need to multiply your x values and then your y values. So we have 1, okay, multiplied by negative 3, so you do have negative 3. 2 multiplied by negative 1, so you do have negative 2. And then so on and so forth. And then to get the summation of xy, you just simply add. That's according to your classmate a while ago. She said that you need to add. Okay? Next, what about x squared? Means how do we get x squared? So to get x squared, you just simply square each number in your x values. So we have 1 raised to 2, so you do have 1. 2 raised to 2, so you do have 4. 3 raised to 2, so you do have 9. And then so on and so forth. And then to get the summation of x squared, you just simply add. So you do have 55. So same thing with y squared also. Okay, so to determine the y squared, you need to square each component or each element in your y values. So we have negative 3 raised to 2, so you do have 9. Negative 1 raised to 2, so you do have 1. 0 raised to 2, obviously it's 0, and then so on and so forth. And then to get the summation, you just simply add all the values under the y squared, so you do have 15. Okay, so after we come up with those values, you can now solve for your coefficient or correlation coefficient. Okay, you can now substitute to the given formula to solve for r. So we do have 5 multiplied by 9. Okay, how do you get 5? When we say n, you're referring to the number of sample size. Okay, it's a sample size. N is equal to the sample size. Okay, so how many elements do you have? So 1, 2, 3, 4, 5. So there are 5. So that is your n. So we have 5 multiplied by 9 minus 15 multiplied by negative 1 over the square root of 5 multiplied by 55 minus 15 squared multiplied by the square root of 5 multiplied by 15 minus quantity negative 1 raised to 2. So your answer is 0.986. 0.986 is closely to 1. So what will be the relationship? So therefore, the relationship is there is a strong positive linear correlation between x and y. It means what if the answer is 0 or negative 0.986? What will be the relationship? Anyone? What if the answer is negative? Let's say the answer is negative 0.986. What will be the relationship of the two given variables? Anyone? What if the answer is negative 0.986? What will be the relationship of the two given variables? Anyone? An idea? What will be the relationship? The relationship will be what?
Strong negative linear.
Okay, very good. There is a strong negative linear correlation between x and y because this value is closely to negative 1. Okay? So we call it a strong negative linear correlation between x and y. Okay? So that's how we compute for correlation coefficient, which is denoted by r. Okay? So for example, let's try to apply the concept on computing correlation coefficient in a particular problem. Okay, this is the problem. The following data represents the number of hours of 12 different students watched television during the weekend. Okay, and then the scores of each student who took a test the following Monday. Okay, letter A, display the scatter plot. Letter B, calculate the correlation coefficient R. So given the data that we have, okay, X will be the number of hours, okay, 12 different students watch television during the weekend. And then Y value, you are referring to the test score, okay, test score of the student who watched television during the weekend, okay. So number of hours. So kapag 0, the test score result will be 96. Okay, the student score will be 96. If the student spent 1 hour, okay, his or her score will be 85. 2 hours, 82. 3 hours, 74. 3 hours, 95. 5 hours, 68. 5 hours, 78. 5 hours, 84. 6 hours, 58. 7 hours, 65. 7 hours, 75. And then 10 hours, 50. Okay, so these are the scores, okay, according to the data given. So let's try to figure out what kind of relationship that we can formulate in this particular problem. Okay. So first we need to come up with scatter plot. Okay. So the Y values, those are the test score, and then your X values, the number of hours watching television. Okay. If you have noticed, what is the pattern of your scatter plot? They are going what? Going what? Going to a negative, right? Decreasing. Okay. So what do you mean by that one? What do you mean by that one? What do you mean by that one? What do you mean by this one? Okay, when we're using the scatter plot, we try to figure out if we can formulate a line correlation. Okay, a line correlation in this particular. If you have noticed, if you will examine, there is a line correlation between the two variables. Okay, and then to justify if there's a line correlation, we need to solve for R. So to solve for R, okay, just follow the procedure a while ago. Okay, so we do have X for the number of hours, and then test score, you're referring to the Y values. Okay, so to solve for X, Y, so how do you solve for X, Y? When we say X, Y, you need to what? You need to multiply x and y. Okay, you need to multiply x and y. So 0 multiplied by 96, you do have 0. 1 multiplied by 85, you do have 85. And then so on and then so forth. What about x squared? How do we determine x squared? Just simply get the square of each component in your x values. So we have 0 raised to 2, so you do have 0. 1 raised to 2, so you do have 1. 2 raised to 2, so you do have 4. And then so on and so forth. And then for y squared, so same thing. Get the square of each component in your y values. So we have 96 raised to 2, so you do have 9,216. 85 raised to 2, so you do have 7,225. And then so on and so forth. Okay? Then what's next? You need to get the summation of each. So the summation of x values, when we say summation of x values, meaning you need to add all the values in your x component. Okay? So 0 plus 1 plus 2 plus 3 plus 3 plus 5 plus 5 plus 5 plus 6 plus 7 plus 7 plus 10. So you do have 54. With summation of y, just add everything. Okay? All the numbers under your y value, you need to add it. That's the meaning of summation. So you do have 908. And then the summation of xy, you do have 3,724. Summation of x squared, you do have 332. And then the summation of y squared, you do have 17,836. So to solve for the correlation coefficient, you just simply substitute to the given formula. So what will be your sample size? According to the problem, you do have 12 different students. So your n will be 12. Okay, so we have 12 multiplied by 3,724 minus 54 multiplied by minus the product, okay, of 54 and 908, okay, all over the square root of 12 multiplied by 332, okay, minus 54 raised to 2 multiplied by the square root of 12 multiplied by 70,836 minus 908 raised to 2. Okay? So the answer is negative 0.831. Okay? Or negative 0.831. So therefore, what will be the relationship of the number of hours spent watching television and then the result of the test? Okay? What will be your score? So the relationship will be, there is a strong negative linear correlation. And Miss, why is it negative linear correlation? Meaning, as the number of hours spent watching TV, okay, increases, the test scores tend to decrease. Okay? So that's the relationship. As the number of hours spent watching television increases, what will happen to your score? It will decrease, right? So that is a strong negative linear correlation. So that's the relationship of the two variables. Okay? Kapag yung isa pa-increase, yung isa pa-decrease, that relationship, we call it strong negative correlation. But if they are both increasing, we call it positive correlation. Okay? Do you get the point? Opposite kasi, yung isa increasing, yung isa decreasing, so the correlation or the relationship is negative. But if they are both increasing, the relationship is positive. Okay? So the relationship is, the value is negative 0.831, so therefore, there is a strong negative linear correlation. As the number of hours spent watching TV increases, the test score tend to decrease. Okay? What about hypothesis testing for P? Okay, this one we call that symbol as rho. Okay, that symbol we call it rho. Okay, a lowercase p. It's a lowercase p, and we call that rho. Okay, R-H-O, that's rho. That symbol we call it rho. Okay, and we call it correlation population. Okay, in our previous discussion we do have mu. Okay, that's a population. It's a symbol for the population, and then we do have capital P, pertaining to the population proportion. So since we're talking about correlation proportion, okay, the symbol that we need to use is the rho symbol, which is the lowercase of p, and then we call it is a correlation population. A hypothesis test can also be used to determine whether the sample correlation coefficient R provides enough evidence to conclude that the population correlation coefficient P is significant at a specified level of significance. Okay? Meaning, in other words, okay, we already determined the correlation, okay, that the two given variables, there is a correlation in terms of the relationship. Okay, merong relationship. It can be negative relationship or positive relationship, but there is. But we need to determine if there is a significant relationship in that particular values. Okay, so to determine the significant relationship of the two given variables, we need to apply this one, yung hypothesis testing for correlation population or population correlation. Okay, which is denoted by P or rho. Hypothesis tests can be one-tailed or two-tailed. I think you're familiar with that one because we tackled it last week. Okay, So if the correlation, so first you need to formulate your hypothesis. Okay. Remember how do we test the hypothesis? We do have 5 procedure. Formulate, formulate the null and alternative. That's the first procedure. Second, identify the statistic. Third, you need to compute. Fourth, decision. And then fifth, that one you need to come up with your conclusion. So same thing, in formulating hypothesis testing, in population correlation, we need to follow the 5 procedure. Okay, first, you need to formulate the null and alternative hypothesis. Okay, so for your null hypothesis, it can be left tail test or it can be two tail test. Okay, depends on the given situation. Okay, so your null hypothesis can be greater than equal, less than or equal, or it can be equal to 0. Okay, meaning your null hypothesis is there is no significant relationship between the two given variables. Okay, but when we say HA, meaning it's the claim of the researcher that no, there is a significant relationship. Okay, so to test your hypothesis, okay, we do have left tail test, right tail test, or the two tails. Okay, so the t-test for the correlation coefficient, in other words, to check whether the two variables is significantly correlated, we need to use the t-test. Okay, so t-test can be used to test whether the correlation between the two variables is significant. Okay, although we found out that they are correlated to each other, of course we need to check if they are significant just to justify your conclusion. Okay, so to check whether the two variables are significant, we need to use the t-test. Okay, so the test is statistics is R, and then the standardized test is statistic will be T is equal to R divided by the standard deviation of the population sub R, or simply R divided by the square root of 1 minus R squared over N minus 2. Okay, it follows a T distribution with the degree of freedom N minus 2. Okay, remember you do have the table, the T distribution table. So you need this one to test whether the two variables is significantly correlated to each other. Okay, so you need the T distribution table. So in this text, only two tailed hypothesis tests for the correlation population are considered. So using the t-test for the correlation coefficient, okay, denoted by the symbol rho, state the null and alternative hypothesis. Okay, this is how we test the hypothesis of the correlation coefficient. Population correlation. Okay, state first procedure, state or formulate your null and alternative hypothesis. H sub O and then H sub A. Specify the level of significance, identify the degree of freedom, determine the critical value, and then the rejection region. Find the standardized test or the T value, okay, which is equal to R over the square root of 1 minus R squared over N minus 2. And then make decision to reject or fail to reject the null hypothesis. Okay? If T is in the rejection region, reject HO. Otherwise, fail to reject HO. Okay? If the value of your t-test, okay, or the t value is located or within your rejection region, then you need to reject your HO. So if you reject your HO, you are accepting your HA. Okay? Accept HA. Interpret the decision in the context of the original claim. Okay? So same example. Okay? So we found out that the number of hours of 12 different students watched television during the weekend, and then the scores of each student who took a test the following Monday has a strong negative correlation. Okay, a strong negative correlation. This time we need to determine their significant correlation. Okay, if there is a significant correlation between the two given variables, and how do we do that? We need to apply the t value. Okay, so the correlation coefficient given is negative 0.831. So to test the significance, we need to follow the procedure a while ago. Okay, so test the significance of this correlation coefficient, significant at alpha 0.01. Okay, so let's continue. So first you need to formulate your null hypothesis and alternative hypothesis. So your null hypothesis, okay, population correlation is equal to 0, meaning there is no significant relationship, okay, between the number of hours spent watching television and the test score. So that is your null hypothesis. Okay? No change. When we say null hypothesis, unchanged statement. Okay? So there's no significant relationship, okay, between the number of hours spent watching television and the test scores result. Okay? But the researcher said, no, there is. Okay? If you're talking about alternative hypothesis, you're talking about the claim of the researcher. The researcher said, no, there is a significant relationship. Okay? So meaning, your HA will be, there is a significant relationship between the two given variables. Okay? And that symbol will be, correlation population is not equal to 0. For your null hypothesis, correlation population is equal to 0, meaning there's no change. Okay? Unchanged statement. Walang relationship daw, sabi niya. The relationship of the two given variables, okay? There's no significant correlation or relationship. But the researcher said, no, there is a significant relationship. Okay? So that's how we test correlation, okay? In terms of significance. So the level of significance is alpha 0.01. Okay? So the degree of freedom is 12 minus 2, which is 10. Okay? And then the critical values are from negative 3.169 to positive 3.169. The question is, Miss, how do you get the critical values? Remember this test? Okay? If your HA is not equal, what test we need to apply? We need to apply the two-tailed test. So using the t-test table, okay? So you check two-tailed and then 0.01 and then the degree of freedom, which is 10. Okay, degree of freedom 10, and then you check here, okay, yung test which is two-tailed, and then yung level of significance, it's 0.01, and then you check yung DF which is 10. Okay, so if you have noticed, the given is 3.169, but since the test that we're using is two-tailed, meaning both sides merong value. Okay, two-tailed eh. So both sides merong value. Okay? Each side has a critical region. Okay? That's why you do have negative 3.169, which is the left side, and then positive 3.169 on the right side. Because we're talking about two-tailed test. Okay? So nandun daw yung mga critical regions. Now, so after we identify the critical values, which is negative 3.169 and positive 3.169, solve for t value. Okay? So using the formula, so the t value is negative 4.72. And remember that negative 4.72 is what? It's within your critical, or within the rejected region. Okay? Negative 4.72 is within the rejected region. So therefore, kung nandun siya, within the rejected region, you need to reject your HO. Okay? Because your t value is negative 4.72. So nandun within the rejected region. So you need to reject your HO. So therefore, if you're rejecting your HO, you need to accept your HA. So therefore, at the 1% level of significance, okay, there is enough evidence to conclude that there is a significant linear correlation between the number of hours of TV watch over the weekend and the test scores on Monday morning. Okay? Aside from the fact they are correlated negatively, you also conclude that there is a significant correlation. And we use that. We can test their significant correlation using this formula, yung t value. Okay? So that is correlation per se. Next is, the fact that the two variables are strongly correlated does not in itself imply a cause and effect relationship between the variables. Okay? If there's a significant correlation between the two variables, you should consider the following possibilities. Okay? What are those? Is there a direct cause and effect relationship between the variables? Is there a reverse cause and effect relationship between the variables? Is it possible that the relationship between the variables can be caused by a third variable or by a combination of several other variables? Okay? It is possible that the relationship between the two variables may be coincidence. Okay? My question is, why do you think that there is a significant, correlation, okay, between the two variables? What do you think is the implication? You found out that there is a significant correlation, okay, between the number of hours spent watching TV and then the test score. Now, what do you think is the implication? Justify the result. What are the factors to come up with that result? How can you justify your result? Can anyone justify the result? After you found out that there is a significant relationship between the two variables, what can you say about it? What can you say about it? What can you say about it? What will be your implication? Just to justify the number or the result that we have. So do you agree? Diba? Do you agree that there is a significant relationship? Okay? There's a significant correlation between the two variables. Of course, you need to justify it. Bakit kaya naging significant yung relationship nila? What are the factors that we can consider? Can you give me one? Anybody? Of course, you need to justify your result eh. That's how we come up with a paper, research paper. You need to justify it. Oh, after you found out that there's a significant correlation, you need to give me implications or factors based on your observation or analysis. Ano masasabi nyo? To come up with that result. What can you say? Anyone? Before we proceed to linear regression, why do you think that the result is there is a significant relationship? How can you justify your result? Why do you think so? Ano yung mga factors just to justify that there is a significant relationship? Of course, if you spend time watching television more than studying, obviously the probability that you will get a low score is closely to 1. Okay? Because instead of studying, you're focusing your mind watching television. Okay? So most probably, you cannot answer the test the following day. Okay? Next is linear regression. What about linear regression? When we say linear regression, okay, you are referring to the predicted value. Okay? We need linear regression to determine the predicted value. Now, Miss, what is the connection of linear regression to correlation? Okay? Let's find out. After verifying that the linear correlation between two variables, okay, next, we determine the equation of the line that can be used to predict the value of y for a given value of x. Okay? So, observe y value and then predicted y value. For a given x value, d is equal to the observed y value minus the predicted y value. Each data point, d sub I, represent the difference between the observed value and then the predicted y value for a given x value on the line. These differences are called residuals. The regression line, also called a line of best fit. Okay? It is the line for which the sum of the squares of the residuals is a minimum. The equation of a regression line, okay, the equation of regression line for independent variable x and dependent variable y is, when we say y hat, okay, y hat, meaning the predicted value of y, okay, the predicted y value, okay, this symbol, yung y hat, we call it predicted y value for a given x value, okay, is equal to mx plus b. M pertaining to the slope, and B pertaining to y-intercept. Okay, so to solve for the slope, so we have n multiplied by summation of xy minus summation of x minus the product of summation of x and summation of y over n multiplied by the summation of x squared minus summation of x raised to 2. And then to solve for y-intercept, so that will be y bar pertaining to the mean, okay, mean of your y value, and then x bar pertaining to the mean of your x value. Okay? So mean of your y value minus the slope multiply by the mean of your x value is equal to the summation of y over n minus m multiplied by summation of x over n. Okay? You can use both. Okay? So find the equation of the regression of a line in this particular example. Okay? First, you need to get the summation. Yan. So we have 15, negative 1, 9, 55, and then 15. So to solve for the equation of the regression of a line, you need to find the slope. So the slope is 1.2. And then look for the y-intercept. So we have negative 1 over 5 minus 1.2 multiplied by 15 over 5. Miss, where do you get negative 1 over 5? That's the mean of your y value. So remember, when we said y bar Okay, pag sabi y bar, you're referring to the mean of your y values. Okay, and then x bar, you're referring to the mean of your x values. Okay. So you do have negative 3.8. So therefore, the equation of the regression line is the predicted y value is equal to 1.2x minus 3.8. So that is the equation of regression line. Okay. So based on the example that we have a while ago, okay, the following data represents the number of hours 12 different students watch television during the weekend, and then the scores of each student who took a test the following Monday. So solve for the equation of the regression line and use the equation to find the expected test score for the student who watches 9 hours of television. Okay? So solve for the regression line. Before we solve for the equation of the regression line, first we need to identify the summation of each. Summation of x, summation of y, summation of xy, summation of x squared, and then summation of y squared. Then after that, we can now solve for the equation of the regression line. First, solve for m, yan, the slope. And then after that, substitute. So we have 12. Why is it 12? That's the sample size. Because there are 12 different students. So that's your n. Okay, so 12 multiplied by 3,724 minus 54 multiplied by 908 over 12 multiplied by 332 minus 54 raised to 2. So your slope is negative 4.067. Next, y-intercept. So mean of your y values minus the slope multiplied by the mean of x values. So you do have 908 divided by 12 because the summation of y is 908. So to determine the mean, get the average of that one. So 908 divided by 12 to get the average. You say mean, you're referring to the average. Minus negative 4.07 multiplied by 54 over 12. Means where to get 54? 54 is the summation of x values. So to get the mean of the x values, 54 divided by 12. Okay? So you do have 93.97. So the equation of regression line is the predicted value is equal to negative 4.07x plus 93.97. So the predicted value or equation, okay, means what's the use of determining the equation of regression of a line? Okay, we need to determine the equation of regression line so that we can determine the predicted value. What do you mean by that one? Okay, so after we determine the equation of a regression line, which is predicted y value is equal to negative 4.07x plus 93.97. So what's the use of this? Okay, what's the use of this one? The use of that one, yung equation, is to determine the predicted value. Okay, what do you mean by that? Yan. Can predict the test score for a student who watches 9 hours on television. So using this equation, you can predict what will be the score of the student if she or he watches 9 hours on television. So ano magiging output niya? So that is the role of that one, yung equation of regression line. Okay, to determine the prediction, to determine what will be the output. Okay? So using that equation, so we have negative 4.07 multiplied by 9 plus 93.97. So the score, okay, so the test score of the student who spent 9 hours watching will be 57. Okay, can be 57, predicted eh. So it can be 57, 58, okay? So more or less, the score will be that kind of, will be in that particular value. So 57, 58, so that's the use of regression line. Okay, linear regression. Okay, now, my question is, what will be the test score of student who watches 8 hours? Okay nga, anybody? What will be the test score? If the student spend 8 hours of watching television, what will be the score? Anyone? Anyone, what will be the score? If the student spend 8 hours, what will be the predicted value? Or what will be the predicted test score if the students spend 8 hours watching? What do you think will be the predicted score? Can anyone?
61.41.
Okay, let's check. Okay, very good. So the score will be 61.41. Okay, so 61.41. Okay, so that is the application of linear regression. Okay, any more question, my dear people? Any more questions?